Today's lesson is going to be continuing factoring, but we are now going to strictly be factoring trinomials with a leading coefficient of 1. And what that means is the number in the very beginning is 1. A traditional trinomial is, one we'll see very often, is ax squared plus bx plus c, which is really just like x squared plus 4x plus 8. Well, this value out front of all the ones we're doing today is just going to be a 1. Tomorrow we're going to cover when that's greater than 1. So as a warm-up, we are looking at going forwards. Last unit we learned how to take two binomials and turn them into a trinomial. So we FOILed it out, or you used your Punnett square method. If I were to FOIL this, I would have x squared plus 1x plus 5x plus 5. And so when I combine like terms, that's really x squared plus 6x plus 5. When I factor out the second one, I get m squared minus 4m plus 6m minus 24. So when I combine like terms in the middle, I really have m squared plus 2m minus 24. And the last one, I have k squared minus 7k minus 3k plus 21. So my final answer should be k squared minus 10k plus 21. So that's going forward. So what we're going to do today is try and take these trinomials and go all the way back to two binomials. So to factor a trinomial in the form x squared plus bx plus c, you must find two integers that multiply to give you c and add to give you b. So basically I'm looking for two numbers that multiply to give me the end but add up to give me the middle. So for example, what two integers have a product of 12 and a sum of 7? If we were trying to factor x squared plus 7x plus 12, we know that when we're FOILing, we know that these first two terms multiply to give me this first one here. Well, to get x squared, this must have been an x and an x. These last two terms have to multiply to give me this 12. So I can think of the factors of 12. So to get 12, I've got a couple options. I've got 12 times 1, I've got 6 times 2, and I've got 3 times 4. And alternatively, those can be reversed. But which of those, if I multiply, will give me 12, but if I add, will give me 7. 12 plus 1 is 13, 6 plus 2 is 8, 3 plus 4 is 7, so that's the one we want. So I know that one of these was a 3 and one of these was a 4. Since it comes out to be a positive 12 at the end and a positive 7 in the middle, I know that both of these were plus inside. So I can check by folding it back out to see if I get x squared plus 7x plus 12. So I've got x times x gives me x squared. Then I've got plus 3x plus 4x, which gives me plus 7x. And then I've got 3 times 4, which gives me 12. So the two integers are 3 and 4. Okay, so we write the two binomials using these integers and then distribute to check. So let's try another one. So I know I'm going to set up two binomials. To get n squared, this must have been n times n. And now I'm looking at the two numbers 9 and 20. So I've got kind of like this product and sum chart here. I want to know the two numbers that will give me a product of 20 and a sum of 9. So it's usually easier to focus on the product part first because it really narrows down your options. So my options for 20, I've got 20 and times 1, 10 times 2, 5 times 4, but I want to know which one actually adds up to 9, and I see it's 5 and 4 because 5 plus 4 also adds up to 9. So I know that one of these was a 5 and one of these was a 4. You could have written them backwards, it's totally fine. When they multiplied, 5 and 4 gave me a positive 20. So they had to be the same sign. They could have both been negative, they could have both been positive. The thing that lets me know the signs that need to go in the middle is this first sign. If that's a positive 9n, then these must have been positives as well, because if they were both negative, then it would have given me a negative 9n in the middle, and that's not what happened. Okay, so trying that again. This one I've got w times w gave me w squared, and I'm doing a product and sum for 18 and 9, so I'm trying to find the product for 18, the sum for 9, so I'm looking at my options. Right off the bat, I'm thinking 6 times 3, because 6 plus 3 is also 9, so this is a 6 and a 3. This was a positive 18, so my signs had to be the same. This tells me that they were both positive. Okay, again, this would have been a squared was a times a. Then I'm looking at a product of 24 and a sum of 10. So if I'm thinking of these factors here, 24, I've got 6 times 4, and 6 plus 4 meet both stipulations here. So one of them was a 6, one of them was a 4. The signs match because it's a positive 24. This tells me they were both positive. Last one here, we've got y squared came from y times y. Then I've got a product of 1 and a sum of 2. Well, 1 times 1 is the only thing that's going to get me 1, and 1 plus 1 gives me 2, so they're both 1s. It's positive, so these signs had to match. This tells me they were both positive. Okay. So this next section, if you'll notice, the number at the end is now negative. Still the same idea. I'm still going back to two binomials. N squared came from n times itself. But now I'm looking for a product of a negative 18 and a sum of a positive 3. So to get 18, I've got 3 times negative 6 or negative 3 times a positive 6. There are a couple different options. I've got 9 and 2, but that's not going to give me any kind of sum or difference of 3. So I'm really focused on this 3, 6 option. So which one of those, if I add together, will give me a positive 3? Well, 3 plus negative 6 is going to give me a negative 3, and negative 3 plus 6 is going to give me a positive 3. So this is the option we want. So I know when I fill it back in, I need to have a minus 3 and a plus 6. I could FOIL that back out. I'd get n squared minus 3n plus 6n, and negative 3 times a positive 6 gives me a negative 18 on the end. Okay, doing the next one, it's the same situation where the number at the end is negative. So I've got x times x. I'm looking to find out what multiplies to give me negative 8, but adds to give me 2. I know to get 8, the most common one I've got is 4 and 2, but one of them has to be negative. So 4 plus negative 2 is a positive 2. Negative 4 plus 2 is a negative 2. I need a positive 2 because this middle term is positive. So this is the option I want, a positive 4 and a negative 2. So when I fill it in, it's going to be a plus 4 and a minus 2. The next one I got g times g gave me g squared. I'm looking for a negative 6 at the end, so I am looking for a product of negative 6, and since it's just g, I know it's a positive 1 for the sum. 2 times 3 gives me 6. I need to look at it both ways, seeing where the negative needs to go. Negative 2 plus 3 is a positive 1. 2 plus negative 3 is a negative 1. So I need the 2 to be the minus and the 3 to be the plus. Last one like this, we've got c squared came from c times c. Negative 45 is the product we're looking for. Positive 4 is the sum we're looking for. So I think of different factors of 45. One off the bat is 5 and 9. So 5 times negative 9 or negative 5 times 9. The one that gives me that sum of a positive 4 is going to be the negative 5 plus 9. So I need to have a minus 5 and a plus 9. So that's what you do if your n term is negative. You just need to make sure you're trying your factors with switching the negative and seeing which one you need to give you the appropriate middle term. Okay, so now I have negative, negative. I'm still doing the same thing. I still know a squared came from a times a, but now I'm looking for a product of -3 and a sum of -2. So things that multiply to give me 3 are just 1 and 3, and I can try the 1 being negative and the 3 being negative. The option that adds up to a -2 is going to be 1 plus -3. So I know that the 1 has to be the positive and the 3 has to be the negative. This next one, x squared, came from x times x. I'm looking for a product of -30 and a sum of -7. So options to get to 30, I know I have 5 and 6, and I know I have 2 and 15, and I know I have 3 and 10. Well, the only one that's going to get me close to 7 is this 3, 10 option. So now I just need to determine which of these numbers need to be the negative. Well, the 7's negative, so it must be the 10, because 3 plus -10 will leave me with -7. So I know the 3 needs to be positive, the 10 needs to be negative. This very much so has a lot to do with number sense, knowing your factors, knowing your integers. It's very important. Okay, so number 11, we've got b squared comes from b times b. I'm looking for a product that gives me -63 and a sum that gives me a -2. I'm thinking 7 times 9, and since 2 is negative, I know the 9 needs to be the negative, because 7 plus -9 is -2. So I need a +7 and a -9. All right, last one like this. This must have come from k times k. And then I have a -64 and a sum of -12. So when I think of 64, I know that I got a couple different options. I know I've got 8 times 8. Well, that's going to give me 0 if one of them's negative, if I add them together. So I need to think about some other options. More likely, it is the 16 times 4, with the 16 being negative. 16 times 4 is 64, and a -16 plus 4 gives me -12, so I know I need -16 and +4. So that is what you do if both of them are negative. It's still all about product and sum. You'll just start recognizing some patterns of what happens depending upon the signs.